Hey everybody, Mr. Ribot back here with some math. Today we're going to review slopes real quick. Um, so probably, hopefully you guys remember these. Slope, is dealing with how steep your line is. This is going to be a concept that you will see throughout your mathematical journey of high school. So if we remember our slope formula, Uh, usually we represent slope with m, y2 minus y1 over x2 minus x1. Um, that's one way of representing slope, right? Um, the other way to think about it is, in this way I like to think about it instead of necessarily memorizing a formula, even though that is ingrained in my head, is this is the change in y. So in math, and actually science as well, we use delta, the little triangle symbol, to mean change. So this is saying delta y, the change in y, over the change in x. So delta x. Um, Another way you can think of it is it's the rise over the run. So how far up do you go, and how far over do you go to take like a step on um, your graph, right, or your function. Let's just do a quick example just to refresh ourselves. So if we have 2 points, 7, 3, and negative 5, 5. So instead of having to graph it, now if we graphed them and then counted up and over, that'd be using the rise over run. Um, Instead, let's use the formula. Um, so it doesn't matter which one you call x1, y1, which one you call x2, y2, as long as you're consistent. Like you can't have x1, y2, x2, y1. That just doesn't make sense, and it would not be correct. I'm just going to say this is our second point, just because it's written second. So 5 minus 3, so the change in y's over the change of x's. So negative 5 minus 7. Now we just simplify. 5 minus 3 is 2. Negative 5 minus 7 is negative 12. Simplify that. Um, so we have a slope of negative 1/6. So every time our y changes by 1, our x changes by 6. Um, and so we'd have to just make sure we're keeping into account the negative as well. Um, so just a little bit more review of it. If we have a positive slope, our line's going to go up as we go left to right. If we have a negative slope, we are going to go down as we go left to right. So a slide's going that way. If we end up with a 0 as our slope, totally possible. It happens all the time. So that would mean that we don't rise at all and we run forever, which means we have a horizontal line. So 0 slope, horizontal line. It is also possible to have an undefined slope, right? And that would mean something like 5 over 0 could happen. Oh, that's not allowed because we're dividing by 0, but that doesn't mean we can't graph it, because this means rise 5, run 0. Well, if we have a point here and we go up 5 and run 0, it would just mean a vertical line. So an undefined slope is that vertical line. So these three can be written using function notation. So f of x equals or y equals, like 5x, negative 2x, and then like y equals 2 could be this equation. This one, though, because it's an undefined slope, you can't write it as y equals or f of x equals. This one would be x equals, like x equals 3. Okay? So just remember those. Couple other things to deal with slope we're going to talk about is parallel lines. So if you have parallel lines, the biggest thing to remember, well, not the biggest, but one of the things to remember, biggest thing dealing with slope, is that they have the same slope. So if this line has a slope of 2/5, say m1 equals 2/5, and then they say, oh, this is a parallel line, which they can do with the little arrows or whatever, they can just tell you, that means that this one's slope would also have to be 2/5. Okay, so that makes them parallel. So they could either just tell you the two slopes and say they're the same, and then you know it's parallel, or they could put the little symbols saying, oh, they're parallel, or they could just tell you they're parallel, and then you know that they have the same slope. Conversely, though, if we're talking about perpendicular lines, perpendicular, ugly handwriting on this thing. So if you have perpendicular, which remember perpendicular means you form a right angle. Okay, so it's the special way of intersecting where you form a right angle. This is where we're going to have opposite, meaning if it was positive, it becomes negative. If it was negative, the other one has positive slope. Opposite reciprocal. Reciprocal. I can't spell very well, so I have to look at my notes when I do that one. So opposite reciprocal. So if you know, let's deal with the same slope here. Let's say this is, once again, m1 equals 2/5. And then we have another line. Either we're told it's perpendicular, they give us the right angle symbol, or they can just say, oh, the slope of the second line is going to be the opposite, so it'd be negative instead of positive. And then reciprocal, remember, means your numerator and your denominators flip. So instead of being 2/5, this one's -5/2. Okay. So when you see that, you know it's perpendicular. They're opposite reciprocals. And yeah, you get two lines that will work out. All right. So the last thing I'm going to talk about real quick in this video is, didn't mean that, is another just more so vocabulary thing that you will see. So if you ever see the words average rate of change, okay? So average rate of change. Now, if it doesn't have the word average there, don't necessarily use this. It'll probably be something different, especially if you see it in like a physics class or upper level math. But average rate of change is basically this formula. So it's f of b minus f of a divided by b minus a. And hopefully this looks kind of familiar because the function value of b, or function value evaluated at b, I should say, and then the function value evaluated at a, well, this is function notation. If you remember with function notation, it gives you the y value. So this is really y2, let me change colors, y2, this is really y1, and then these are the two things we substituted into the function, which means these are our x's, so this would be x2 and x1. You'll notice it's the slope formula. Okay, so if you ever see something that asks you to find its average rate of change, you're really just doing slope. Okay, so you'll see that with the practice we have in class. All right, so hopefully you enjoyed the video and have a good